You're very welcome. My name's Claire Penny. I'm a partner in a consultancy called Strategy, and I'm also a director of CitA. This is the fifth event, and today we're going to focus on AI, MMC, and automation from design to delivery. And the webinar is due to run from 12 now till 1 p.m. and it will end 1 p.m. So we have a lot to get through. So I'll move on. We want to thank our sponsors very much. These are the companies that really help us to put on events such as this. So from the bottom of our hearts, thank you very much to all our sponsors. We'd just like to mention as well that this series is running in collaboration with the logos on this slide here, and it's been an extremely successful event. And we're very grateful and thankful to all the logos again on this page. So far, we've had around 600 individual attendees to this series, and we're on 5 of 6, as I said. Without further ado, I'd like to introduce our speakers today. So, as I said, I'm Claire Penny. We have Jacqueline Lakubara, sorry, Jackie, who's the director of the Information Lab. We have Porrick Walsh, who's actually in Melbourne, Australia, giving us a real international feel. And Porrick will join us at the Q&A, but we do have a recording of his presentation. And we also have David Flynn, who's the co-founder and COO and CISO of Cope AI. The agenda for this morning is a very brief intro opening address from myself. Then we'll jump into Jackie's presentation, who's going to ground us all in what we need to do in terms of data to build a solid foundation. We'll then go to Porrick's recording, who's going to show us a practical implementation of AI. And then we'll move to David's presentation, who will show us AI and anger, if you like, AI being used at scale for production. Then we'll come back, and if you could all put your questions into the chat, into the Q&A section in the Zoom, we'll get to as many of those questions as we can before the closing address. So that's enough from me, and without further ado, I'd like to pass over the reins to Jackie. Jackie, the floor is yours.
Great. My name is Jackie. I'm head of PMO for the Information Lab. We are a Dublin-based data and AI consultancy. We've been in business for about 10 years now, and we work within the construction and more specifically in the MMC space. And so what I'm here to kind of talk about today, as Claire mentioned, is essentially how you ground kind of your usage of AI and your plans around AI in a solid foundation. So just to kick us off, I want to be clear about what this statement is and isn't. First of all, it's not a criticism of AI, right? This whole session is about what AI can do, and it can genuinely do remarkable things. And I'm actually really excited to see, and for you all to see Porrick and David's presentations today on that. Really, this is a description of what happens when you deploy it before you've dealt with the thing underneath it. And in construction, and MMC specifically, that's a data problem. So I want to show you kind of what I mean. So one, I'd be really surprised if anybody on this call hasn't been in a situation where your program report landed after you've already made a decision. And so the gap between what MMC promises and what most businesses are living isn't a methodology problem, right? The methodology is right, it's sound. It's an information problem. So you've got design in one place, cost somewhere else. Nobody's sort of really joining up the dots. You have shop drawings that don't match the model. It's found at installation and not before. And so each project is sort of starting over in some sense because what went wrong last time doesn't really get captured in a way properly that you can use reliably and fold into your kind of centralized operating approach moving forward. And that's not a new problem, right? So what's new about what we're doing now is what we're able to build on top of it. And that's really where AI, I think, comes into play. AI is a multiplier, right? And that's really what I want you to take away from this slide. It takes the patterns in your data and amplifies them at speed, at scale, and with a level of confidence that can be genuinely misleading. We've all been there. If your information is accurate and connected, the output is useful. If it isn't, and in many businesses in this industry, it isn't, well, at least not fully, you get wrong answers delivered with authority faster than any spreadsheet ever managed. And so that's really, I think, what matters for this group. When AI informs a professional output, a cost plan, a specification, a program, the professional who acts on it also carries the accountability. not the tool, not the platform, the person. And so the trail back to trusted information isn't a governance question, it's a liability question. Which brings me just to something that I'd like you to kind of sit with for a moment. Um, Really practical question, right? So, who in your organization is using AI right now and on what? We hear from senior leaders all the time that loads of folks are paying for ChatGPT themselves, or in some cases Claude, or some of the other kind of industry leaders out there. I mean, they're paying for it as a monthly subscription, and I get it, right? Like the tools are genuinely good; they're really useful. I'm not going to sit here telling people not to use AI, but at the end of the day, bid strategies, cost models, specifications going into a consumer tool with no enterprise terms, no governance, no record of what it was working from. When that decision gets challenged, and certainly in this industry, they get challenged all the time, someone is going to ask what the AI was grounded in, whether the information was current, whether it was even yours to share. And that's not a technical question, right? That's a professional liability question. So you might be thinking, okay, so we sort out the governance, get the right tools in place, and then that's the problem solved. And that's partially true, but it's not quite the whole picture. The technology is not the hard part, right? The hard part is that site teams have no incentive to enter data that creates a record of something going wrong. And so the information that matters most is oftentimes the hardest to get. The hard part is that everyone agrees they'll sort the information at handover, by which point the costs have already hit. The hard part is logging something properly. That logging something properly takes more time than a simple text message or a quick phone call. So they're going to default to using those tools every single time, and they're going to try to exchange information fairly quickly. What changes here is not a better platform. It's making the right thing easier than the workaround. It's giving people the tools and the incentives to be able to enter information correctly. And it's not just a matter of telling them to do so. It's pulling the information requirement in the contract from day one, because if it's not in the contract, it's a wish and not an obligation. And there's a certain amount of working with your people to make sure that the barrier to entry to actually get you the information that you need is as low as possible. And there's loads of sort of AI and data tools we'd recommend around that. But ultimately, this all comes from the top, right? You can't push information discipline up from below. So now I've been kind of talking about this quite broadly, but I want to talk about this specifically in the context of MMC. So the information dependency in MMC is not incidental, right? It's structural. So there's design intent, specifications, production records, site data. It's all generated by different teams and different systems and at different points in the project. And so the value of MMC, the repeatability, the cost certainty, the ability to improve over time lives in the connections between those things. And the connections only exist if the information is structured enough to make them. And so a specification that lives in a PDF can't be queried. A production record in a spreadsheet can't be compared against what was actually installed. And a site information in a photo can't be learned from at scale. And so this is contractual as much as it is technical, right? So where responsibilities for as-built information aren't clearly defined, and they often aren't, they arrive inconsistently. Teams end up sort of rebuilding data that should already exist, and the next project starts from scratch again. And so MMC is only as scalable as its information model. And that's not a technology statement, that's a business model statement. So how do you actually go about it? So for starters, this isn't, you're not looking for a transformational overhaul. The fundamental kind of, our fundamental take on this isn't a matter of having everything sorted before you begin. Step one is not a technology project, it's a conversation. So you're mapping where your information actually lives, find where your joins are breaking, and then honestly audit what AI tools are already in use in your organization, because some of them are being used without anybody having signed off on it. Most businesses that do this find that the pictures is often more fragmented than they thought, and that finding is incredibly useful in itself. And then step two is connecting the flows that matter most and making that a contractual requirement, so not an afterthought. So one project, you prove out that solution works, and then you scale up from there. And then step three is typically where AI would come in. So grounding it in information that you control and trust, starting with retrieval and comparison, querying specs, catching discrepancies, and then building towards more prediction as the information gets better. The sequence here absolutely matters. Step three doesn't work without step two, and step two doesn't work without the first one. So that's just kind of our approach briefly, just for context. And then a little bit about us. So I mentioned we're a data and analytics consultancy. We normally work with businesses in construction and MMC, and the problems that I've been describing are the ones that we work with clients on day to day. We typically work with whatever technology and contracts are already in place, and we're really, I can't stress this enough. We don't recommend kind of ripping and replacing, right? So if you have many of you have existing technology stacks that you're working with, you have existing processes that often work. It really is about connecting the dots. Okay. So there's three questions that I want you to kind of just take away from today. One is, can your project data flows from design intent through to production come to site and then come back again? So are you able to map out that loop? The second is, do you know what AI tools your team is already using and what's going into them? And if you don't, there's a whole methodology around sort of shadow AI audits that I would strongly recommend. And if you reach out to me, I'm more than happy to send that over to you. And then third is, if there was a professional decision on your last project that was informed by an AI output, could you say what that was grounded in? And I'd say if any of those kind of land uncomfortably, that's probably where a lot of the work starts. Anyway, I'm again Jackie Lacavara. I'm head of PMO at the Information Lab. And if you want to talk about where to begin, my email's on the screen, and please don't hesitate to reach out. Thanks so much.
So, hi everyone. I am David from Cope. I am from went to uni in DIT back in the day, 2003. Graduated from architectural technology. So good grounding, similar to some people on the call. And since then, have gotten into the world of MMC and offsite construction through my own company. After many years working in BIM management, and then that's essentially evolved into the new scary world of AI. So I've seen the presentation that we're now swapping over with, which really gives a incredible grounding in relation to the architectural intent and the way that AI can be utilized for architecture. So what I'm going to do is I'm going to focus on the MMC piece for everyone today. So a little bit of an overview of who we are. So we are London based. So I ran away and live in London now, unfortunately. And we are basically focused on using AI tooling to productize designs. So we have a really kind of deep focus on the things that make up a building, whether they be pre-manufactured, whether they be assembled on site, but really breaking it down to the componentry of a building. And trying to move away from the idea that everything needs to always be unique snowflake. The reality is that very many components in one building are the exact same as in another, just arranged slightly differently. So our core focus is a web platform that really drives the ability for you to be able to understand design risk, be able to see your carbon impact, and then driving forward into QTO and fabrication. So I'm not going to get into the full detail of what the platform does today, but I want to kind of give you a bit of a background on the journey from MMC focused only into AI for MMC that we've had over a few years. So I've always loved this slide. This slide is quite old. We've had this for 5 or 6 years, and it's the core of our business, and it's the core of our thinking in general. Is that when you think about the things that go into a building, there's three ways to think of them. One of which is that the things that you would buy off of a shelf, very many things that, your FF&E in particular tend to be, they'll have a line item, they'll have a code, and you pop them into your design. You configure some things, you might test and flex certain pieces of design. Bathroom pod is a really good example of that. And the thing that we focus on is the computed elements, things that are essentially start off monolithic like a floor or a wall, and you break them down into all of its componentry. And that really allows us to start thinking about what would happen if you used AI tools to actually support that journey. So I'm going to show you some practical examples of that today. So where do we start off with? Initially, we started to focus on, when we talk about components or elements or parts or whatever language we want to use goes into a building, we wanted to focus a bit more on the system. And we've landed on the scenario here where a lot of our customers or partners that we work alongside tend to have a huge amount of IP that goes into what their product is. Like they're manufacturers, they make a wall panel or a floor plank, and that is what they do, and they make them really effectively. But what we tried to do is to actually help them develop their catalog of products really around the idea of the context of the design. So here's some examples of some of the work that they would have provided with us, in collaboration of here's our product. And then on the right side, you can see how we're starting to think about how we would execute that in a design tool. We'll get into that in a few minutes. So what do I actually mean? So the baseline is that we all know that design work evolves over time. We start at our early design stages, we move through into detail, and then we move into actual construction phase. And so what we try to do is to say, well, we always start with design intent. What are we trying to achieve? What's the industry trying to achieve in relation to the particular building? So you'll set out a particular spec. And the tooling that we're now starting to evolve towards with this AI-generated approach is that we start to break it down into all of the pieces that would be required to build that element, but also then tied to the supply chain and focused around what actual boarding are we using, what actual steel framing are we using, what insulation is there, how do we open around a fire penetration, how do we open around a door, and then obviously giving us some of those outcomes that we have, which is kind of core to our focus in relation to being able to reduce the labor and reduce the material waste, which I'll get into in a second with an actual case study for you all today. So really high level, just before I actually show you the tool running, and then we can kind of get into where AI is fitting into this. We're basically, looking to be able to say, you do what you want to do in your design space. Model it in Revit, model it in Ecosim, model it whatever tool you need to. And we'll start to break that down into its different products. So, the steps that I'm showing you on screen are not really the core point today, but I just wanted to give you a feel for going from design intent, where what you'll see in the next session is really kind of focused around being able to accelerate that with AI tools all the way through to fabrication. And in this example, it's in Tekla for actual implementation of what's happening on the factory floor for those elements. Now, the way that this is working and the reason that we've transitioned so aggressively into the AI space, and what I'm trying to encourage people to feel today, is that so much of MMC is around the rule sets inherent in a product. The way that a particular piece of plasterboard is nearly typically always 1200 mil. They tend to come in particular lengths, they have particular depths, they perform in a certain way. There's a really rigid set of rules that we're able to leverage and able to utilize. And so what I want to encourage people to think about when we move into these AI toolings is, while these tools hallucinate regularly and they can make a lot of errors, the infrastructure of what you're actually providing in the first place is where you can really capture the value. And it's kind of aligned to what Jackie said earlier on. If you can understand what the product is actually supposed to do and all the things that will go into your design, you've already solved many of your issues. So what's on screen is just an example of us looking at simple panelization of a wall. This stuff feels very normal and natural. You put a board on a wall, you overlap the boards for fire. It's not that complicated. But what the AI tool is seeing is very, very fixed rules. If this, then this, then this, then this. And it really allows us to do quite clever things off the back of that. So, thinking about that, I've got a few slides here where we just kind of dive into a bit more of the detail. I won't get into this in particular, but it shows you that our thinking is like, what exactly is happening in a building? What exactly is happening in relation to the transport and the installation steps? What do we need the AI to understand beyond just giving it some very generic kind of actions to follow through on? So the core concept of what we're trying to achieve with the AI tooling that we've now brought into Cope and for our customers as well is to move away from what you see on the left, which is a kind of a relatively simple design process. We are designing a floor of a home. It's got walls and doors and windows. It's got stairs. It's got all the usual things in there. But we're very much driven by the tooling that we use. So Revit is going to work in a particular way. ArchiCAD will work in a particular way. What we're trying to achieve is actually something that's closer to reality that's happening on the ground. So what is actually making up that model? And the example I show you on the screen on the right there is actually a real conversion of the one on the left that we did for one of our very first partners. where they wanted to break it down and actually manufacture everything themselves. So it was a volumetric modular company in the UK. And they wanted to know all of the OSB board, the plasterboard, the insulation, the fixings, the brackets, blah, 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 everything. They wanted to understand how many of them there were. So our tooling moved from the left to the right. That was long before the AI tooling came on board. So things have changed aggressively, and I'll show you that near the end of this session, which is kind of exciting. This was someone clicking 20 buttons in Revit. Still very fast, but it took a lot of time. It produced a lot of information that wasn't particularly needed. And I'll show you where this kind of landed in as we go forward. So just to kind of show you COPE in general, and this is a kind of an example of what we're trying to achieve, with a standard design. So you're bringing the design into the tool. Here we're just going to isolate a single floor. And what we're trying to focus on is what do we actually need to put into this building to build it. So you can see on the left here that we're focused on the external walls and the internal partitions. And the tool's just finding the spec. So it's basically saying you're an internal wall, you've got a 60-minute or 30-minute, you're an SFS system on the facade. And what it's done is it's started to create all the framing for those elements. So you can see the framing on the outside. As I turn off the background file in a second, I should disappear. And we should see then all of the wall panels that we placed. Now, what I want to get across here is that this is not just breaking things down. And where the AI and MMC ideas come together really, really quite profoundly is what we're focused on here in this red element is actually saying, I don't think your system would work here. So I'm going to tell you that there's a bit of an issue in the way that the door opening, as an example, is in the wall. It's telling me that certain issues really need to be resolved in the design step before COPE is going to run all of those different systems. So you can see all the metrics that we're getting at, which is typical for this type of tooling. But the real core focus there is to say what can be built and what can't be built at speed within the file. Now, that's just a quick overview of the tool. I'm not going to get into it too much because what I really want to show you is later on, but I just wanted to kind of give you a feel for what happens when you do this practically and actually utilize this. So the numbers that I kind of want you to focus on is the very bottom left of this screen. So we've 9 ton and we've 20.68%. Now, that was what they were expecting to have in this particular building in London through the work that we've done. Now, after we'd ran the process and actually delivered the work within this building in London, we were seeing a halving of material waste. That would have been incredibly difficult for a person to do. So what we were basically saying is, these are the constraints of the material. These are the things that the material can and can't do. It doesn't like to be here. It likes to be here. Let the tool run and run and run, and it will find a scenario that is both buildable and cost effective and reduces the carbon impact on the building. So this is just focused on the internal partitions for that one scheme, but I'll show you kind of where we're heading towards in the future. So if you can bring these two things together, MMC with its rules, its understanding of complex situations, the way that rules should work, coupled with the AI tooling that we now have, it's a hell of a combo to bring together. Now, beyond that, what I kind of wanted to get into is something where we've landed in the last 6 to 8 months, which has been I don't know if anyone on the session has had this impact on their business, but since October last year, the tooling essentially has become as good as a developer. We're able to basically tell the things, and it's able to supplement our team in a very, very impressive way. And what it's really changed for us is the idea that we don't want to just make the tool a bit better. We don't want to improve certain aspects of it. We don't want a better mousetrap. What we actually want to be focused on is actual systematic transformation of the way that we're working here. So can we do things that we couldn't have done before, as opposed to doing some things that we can do a little bit better? So kind of changing the dynamic of those two. And to give you a feel for where we were in, let's say, October, November of last year, is that these were the 5 categories of things that we were able to configure. We can put these directly into a design off the bat, not a problem. All of them fully operational and working on real schemes. But what we then did is said, look, guys, we have really, really impressive AI tools out there at the moment, but we're unsure how to utilize them. So we ran a hackathon in the team, and we basically said, we want you to advance that list of categories. So if I just go back to that, I want you to fill the blank space on that slide. And we have 2 days to do it. So what we wanted to do is to say, you understand how many MMC systems would work, how traditional construction products would work, fill all of that information into the AI platform that we've built in-house, and start to actually utilize that directly. So as an example, how can we do ceilings and how can we do multiple types of ceilings? And what that's led us to is that, and these are very sketchy. This is only very recently, but we're able to build ceilings without having to do anything. So this is just a simple example of us being able to place all that geometry without having to do any particular work beyond the initial research that we did. That was also then coupled with some primary framing, some composite deck, also then relating to each other. And the AI was understanding that, well, you've got to cut your systems back. You've got to have fixing details here. So obviously very embryonic, early days, but it's allowed us to go from it taking 2 years to do a product category down to probably 2 or 3 months to be able to do a category, which is very exciting. And then that's obviously then expanded into other categories that we're focused on with contractors here in the UK. And what that then allows us to do is to really ramp up all the things that we can work on. So what I wanted to kind of get across for everybody is that one of the things that we've learned probably the hard way is that you can use these tools in anger and you will get decent outcomes. But if you don't align them to your own company vision and your own process and your own aspirations, they tend to steer you awry. So what we've focused on here is to say we are already a very competent product configurator that's hyper focused on expanding that capability as opposed to streamlining other things that we might find value in, but it isn't core to the USP of the business. Now, I'm going to kind of wrap this session up a little bit with something that is relatively new. And I wanted to articulate what this is before I show you the video, because it's a bit of an interesting one. So there'll be many Revit users on the call, and there are tools coming through at the moment that are web-based, one of which is called Conic. And it's basically, very similar to the way that Revit would work. You can design your 3D BIM models in there, and you can start to elaborate on what your designs are in a really effective way. We did a collaboration with them, and I just wanted to show you the outcome of this. So this is what I'm going to show here is completely autonomous. So there's 3 main aspects to this. So the first one is what we call headless. And this is the best way to think about this is that if you opened up Revit, or you opened up Forma, or you opened up Tekla, any of these different design tools, that all the capabilities of another tool would automatically work. You don't have to do anything. There's no installing things. There's no connecting things. There's no API. There's none of the messing around that you would need to normally do. It's just a simple attachment within that tool that allows you to see all of that product configuration happening within that model live. The second part of that is autopilot, which basically allows you to say, I'm working at an early stage design. I don't really know what the specification of something is. I kind of don't care. Like, I want something that looks right. I can get a bit of an understanding of materiality and a bit of cost. I can maybe understand a bit more carbon information, but I don't have to be super precise. So autopilot basically suggests what you would do. It would basically tell you, look, you've got a wall that's 120 mil wide. It's clearly an internal partition. So let's single board it on both sides and put a particular stud from a particular manufacturer in. So it automatically does that for you. And then the last piece of this is the agentic piece, which you'll hear about in the next session, which is really allowing the tools to go off and do things on their own. So I'll show you this video, and hopefully it runs okay. I've slowed it down a little bit. So what we've got here is we've got the agent on the right side. And what it's doing is it's finding the walls that it wants to work on the right side. So it started to run. And what it's done is it's found the walls and it's automatically placed all the boarding, all the studs into all of those walls. And it's given us the metrics that you see on the right side. So it's given me a review. It's also found a couple of walls that it doesn't like. It's like, you're not actually going to be able to build this wall. Great example is that door's in the wrong place. So the architect is going to go back in there and move that door, and instantly it's completely reframed. It's also found its partner. It's reframed that wall too. So this is nothing to do with us. We're completely removed from the process. It's just running our logic. And so again, the designer is going to move that door and it's going to refresh the walls that are associated to that. And you can see at the top right corner there that it's listening for activity. So it's waiting for you to do a thing and it's automatically fixing the problem right behind the steps that you make. So really kind of key ability for us to be able to bridge the really high speed abilities that we have in the AI world, but also with real products, real things from the supply chain, whether they be from a British gypsum or a Saint-Gobain, whether they be a precast concrete system or whatever it happens to be. So you can see here, all of that was automatically placed directly in the model, automatically from the AI system. Now, I'll just kind of wrap up with a very simple thing because you can see the metrics that we're getting out of that as we run, but that's kind of par for the course. What I wanted to kind of get across for everyone is something that what's the journey and where do we think we're heading? My background is in architecture and BIM management, so I'm very familiar with. Apologies for the REBA. I didn't put my RAI steps up here, but the REBA plan of work to lay out how we move through design, moving from something that's incredibly strategic and relatively vague to things that are real and tangible at the end. We see these tools coming together with pre-manufactured or MMC processes and AI coming together to allow us to do something that really compresses this down into a very, very condensed, very high speed world. So generative optioneering, being able to test ideas, as you just saw in the video, very, very quickly, understand how a product would work, then linking that directly to the supply chain and having that instant productization directly in the file, and then having all of that information essentially create a digital twin because you're actually putting products into the file. So really exciting new world that we're hopefully moving towards. It's going to be interesting how we all interact with that, going from generative optioneering all the way through to automated assembly in the build. So the next session will really kind of give a bit more, grounding to what I've discussed here. But like, I just wanted to kind of.
Porrick, are you ready?
Yeah, all good. I'll kind of skim through
Perfect.
basically my presentation and
Yeah.
awesome. Apologies for that too, guys. I'm based in Sydney, so been a little bit difficult. Yeah, so thanks Claire, Alan, and the team for invitation to speak today. I'm gonna fly through this. I'll speak really quickly, but I'm digital and design technology manager at Grey Pucksend. I've 10 years of experience. Previously in Ireland, I worked in a couple of practices, OMP and RKD architects. And now I work in Australia for the last couple of years. The architecture firm that I work with, we've about 150 professionals. We've been in business for 30 years and we've 4 studios nationally in Australia. In terms of just, I guess, a little bit of context and background before I kick off. In today's session, AI isn't really a technology conversation, it's a people conversation for me in my role. It was about embedding it into the culture of our organization. So a quick overview of what I'm just going to run through for the context and background, building the foundations of AI in practice, some practical examples, and then what's next and what we're kind of basically concentrating on in our firm. So why AI matters, just 2 charts here that I wanted to highlight. One from Anthropic, who are the developers of Claude, architecture and engineering and construction I've highlighted. Here, basically, why architecture and engineering is more exposed to AI is just due to the volume of information, coordination, and documentation. Because construction is more harnessed by the physical environment, it's a slower adopter of AI. So there really is an opportunity in architecture and engineering, and we're seeing that it's a slower curve. I'm based in Australia. A lot of the big tier 1 architecture practices and engineering firms are really leading the curve and edge in terms of AI adoption, while as the tier 1 contractors are slow to evolve. Another handy little diagram that I've put in here on the right is just where it gets its facts. That's why there's a few suspect websites there. That's why it's really important when you're leveraging AI's information that you set some guardrails and manage the data and governance around it. Risks is a really important one. So there's news articles every day on LinkedIn. Everyone has it on their news feeds. One that I'd just like to highlight there is Claude. So a technology company brought in Claude into their environment. They were using AI agents, and Claude basically deleted the company's database and backups as well. So there is massive risks there. So it's really important if you're working in your firm or company that you put some guardrails and governance around what you're working with. In terms of data, AI is only as good as the data behind it. Um, Data first approach is really important instead of an AI approach. We learned that from the start when we had a little bit of shiny object syndrome. We were jumping to all different AI platforms out there, playing around with it, but we didn't really understand. It was kind of lessons learned that the data is really, really key. Basically, garbage in, garbage out. So building the foundations. So it was about implementing a strategy. So we had six points that we really wanted to concentrate on: structure and organize the data, mitigate security risks and establish guardrails, identify gaps in business opportunities, and then prioritize ease of use and rapid adoption. That was a massive one for us, number four there, just due to the varying skill level in an architecture practice. We were trying to teach people from partners down to grads and interns and everyone in between. So that easy use was really, really important. And I'll show in my follow-up slides, I guess, what we implemented and did to bridge that gap. Scalability and integration into our software stack really key as well, using APIs, and then vendor neutrality and vendor lock-in. We looked at a couple of options in our AI strategy in terms of who were we going to go with in terms of a software vendor. We didn't want to be tied into the Microsoft environment, so we basically created our own AI tool. We had various areas for our data set, so Mail Manager, our file management system, SharePoint, OneDrive, Deltic Vantage Point, which is where all our human resources, cost management, everything like that lives in there. Autodesk Construction Cloud, which I think everyone in this call is familiar with, and SAI Global, some of the standards, global standards, and we also hooked into the Australian and National Construction Code information. We gathered all that data, and then it was about organizing it and structuring that data, and then we could leverage AI from there. So with any tool that you're trying to develop in-house, you get board approval. So we had a little bit of strategic value for the executives. That little image there on the right was probably my life for the last 3 years. Our partners and business owners basically asking where are we up to? We want AI. We don't know how to do it. So it was about me and the team basically, um, I guess, taking a step back and seeing how we could implement a strategy that works for the practice. We started it small with a tiny little demo user group, got a proof of concept, a budget in place, and then we scaled it from there, which I'll show in the follow-up slides. So enough on the context. So AI in practice for design and delivery. This was the first, I guess, initiative that we started. We named it Grace, a nice, approachable, easy name. So we created an app and a web-based browser. Admittedly, we probably over-engineered it at the start. We created too many different models using narrow AI. So it was a little bit over-engineered. Team members found it hard, I guess, to leverage and understand different models for different purposes. So we had ChatGPT, then we had loads of other models in our environment. So one for like a digital BIM manager, a general, which was on like our company internet data, NCC standards, that's Australian Construction Code standards, a bids and marketing model as well. And then we had one for contracts review. It didn't, on the first initial release, it didn't go as well as we I guess, wanted. We reviewed everything, the usage, how it was being utilized. So we made some changes. We basically consolidated into this was a closed environment that we created. So they had ChatGPT that they could use, except we closed out the environment. So they had all that rich data they could use for summarizing emails, doing RFTs, all things like that. And then when we stepped across that line, that's when we moved into the company data. And that's where we're leveraging all those APIs into those other platforms. And that was really, really powerful. It was simple to use and they understand it. These are our two models that we want to use. So we scaled that from about 10 users up to 140 team members. So basically covering the whole practice, which was great. Um, as part of that second release, then because we're an architecture studio, visualization and aesthetics is really important. So we released two image generators as part of that release, as well as a video generation tool. Because we had an open tool where we weren't tied to a particular software vendor, then we could harness Google in this instance. We found their tool to be Nano Banana and Google Gemini to be a little bit more superior. So we created two models. Then we had Grace Images and Grace Images Pro. The difference between them is Images Pro was like top of the range 4K quality, really high end renders that you could actually produce and give to the client. Skimming through this. So enough talking about the AI. I'm just going to show what we used in the practice in terms of this was the UI. I've sped up this video, but it looks very similar to ChatGPT. So it's easy to adopt. The key difference here, it's secure, it's controlled environment, and it's integrated into our Microsoft authentication and connected into our internal knowledge. So we have those guardrails in place and security with two-factor authenticator as well. And this is just a video of me going through ChatGPT, then into Grace. So feeding into our Grace library and then showing some of our image generators there. So they can obviously upload whatever images they want into this environment and leverage AI. We wanted to make it freely accessible to everyone in the business. It doesn't matter what role they are. We didn't want them tied to their own personal accounts. We wanted to leverage it and use it across the wider practice. These are just some quick examples of Grace Images Pro. So this was Lottie Duty Free in Brisbane International Airport. The image on the top left is an Enscape image just created in Revit. And then the team are highlighting in boxes to prompt using text prompts to put in products and brands into those particular areas. And that was the resulting outcome. So you can see the speed. So that was created in minutes. The team had about 20 renders to do for the airport in that instance. So they blew through this piece of work. There is limitations, obviously. Control is a hard one, and because it's AI generated, it is fictional. Some facade remediate here in Sydney CBD, so we're testing materials and facade treatments. There were some of the facade types there on the right, so we could do quick iterations. Obviously, highly conceptual, but the speed of this is we could sit in the room with the client and actually go through and get a look and feel and sketch through it and leverage AI and really get into what they wanted and what we wanted. So it's just opening up a lot of possibilities. The speed, iterations. A Rhino model here in the top left, where we're prompting for a master planning and landscape concept. This was a particular project where we're stuck for time. We had to get a request for tender in, so we're leveraging AI to speed up the process there. And then our interior team also leveraged AI using mood boards, so it's super quick for that kind of use case. So what's next? I'd like to finish, I guess, some of the areas we're currently exploring in Great Puxen. That these are fresh off the press. I guess we're using these right now. It's part of the R&D research and development in the company. So we're currently working through these. So Revit remains our primary design and delivery platform. So naturally, we've been, I guess, exploring how AI can be integrated directly into that environment. So here we're testing Revit via an MCP, Model Context Protocol, allowing the model to understand project concept and generate content from simple text prompts. So it is still early days, but what I'm doing in this example is putting in a screen grab of a floor plan, uh, feeding it into Claude, and via that model context protocol, it's drafting up and creating that floor plan, which I guess stores and walls in it. It's by no means perfect, but I guess the speed this is evolving, it's something to look out for. Our longer term strategy is to integrate this Claude environment into Grace. So Grace is our one-stop shop for AI within the practice. We don't want to be creating a siloed effect where you have multiple models and different platforms because you don't get as much usage. So we want Grace, that's your AI app or web-based browser. Do you want to use it in Revit? Do you want to use it in X, Y, and Z platforms? Just another quick example, Claude again, here we're doing a model health and auditing as part of the design technology team. In the past, we've had to rely on third-party tools and go in there ourselves manually. So we're using Claude now to, I guess, check and audit and see what the issues are so we can get right to it and fix it, speed up time and get that team member back to working at full capacity. And the final one, then, sorry, very quickly, we're exploring what has become known as vibe coding. So using AI to rapidly create applications and workflows. In this example, we're just testing an AI app, our internal app I created to manage project actions, RFIs, etc. So it's still early days, but there's massive opportunity out there, I guess, to quickly build simple apps. So for this one, it was a business need in the organization that team members were using, let's say, Excel documents for managing their RFIs. They might be working across 10 projects. So we wanted to create our own app in-house using Claude as a secure environment. And sorry, now I'm flying through this, but if you do want to connect with me, apologies for the pre-recording video issue. If you want to connect with me on LinkedIn or scan my digital business card, feel free to.
Thank you, Porrick. That's brilliant.
Thanks, guys.
Thank
Sorry
you. Thank you so much for doing that. And everybody, Porrick is in Melbourne, so it's very late at night for him. So thank you. And thanks everybody for being patient. So in the last couple of minutes, I will just share, just to wrap up. Let me share. So, yeah, so anybody that doesn't know, being part of CitA gets you lots of goodies. So get you with CitA SkillNet training and funding opportunities. So for these courses here, you can see you get up to 60% reduction or funded for these courses. And you can see AI for business is in there. So that's a great one. Yeah, so the next event, I think, there's a SkillNet platform initiative that you can use this QR code to access. And I think I have actually missed a couple of slides. We go back. Yeah, so here's other funded opportunities, 30% off these courses. So it's very beneficial being a member of CitA if you would like to join as a company. And then finally, just to say that event 6, and it's 6 of 6, is scaling AI, whole life performance, carbon, and ESG, and that's on the 23rd of September, between 12 and 1. And just in the last few seconds that I have, I just want to say thank you to everybody who's participated today, both in terms of our fabulous speakers. Thank you. And thank you, Porrick, for being put on the spot and coming up good. And thanks for everybody for your patience and for joining us. And we look forward to seeing you at the next event, which is the 23rd of September.